Hello students. We will continue our discussion on alkenes. In the last session, we had discussed the preparation of alkenes from alcohols, that is by dehydration, and from alkyl halides, that is by dehydrohalogenation. Okay, we had discussed the Seitz-Zaff rule as well as the Hoffman's rule. We have discussed what is a Seitz-Zaff product and what is an Hoffman's product. Okay, let us now discuss about some reactions of alkenes. Okay, reactions of alkenes. So in the last session, whatever we had discussed was preparation of alkenes. Now let us discuss the reactions of alkenes. Alkenes are the compounds that contain carbon-carbon double bond, right? Since they contain carbon-carbon double bond, they undergo addition reaction. Since there is a double bond, you can add across these carbon atoms. So they undergo addition reaction. For example, if you take this alkene and if you add HBr, HBr dissociates to give you H plus and Br minus. So H plus will get attached to one carbon and Br will get attached to another carbon. So when addition takes place, double bond gets converted into a single bond. To one carbon, hydrogen gets attached and Br gets attached to the another carbon. So this is what happens. So this is general addition reactions that we come across. So alkenes undergo addition reactions. So alkenes undergo addition reactions. Why? Because they contain a carbon-carbon double bond. Hence addition across the carbon-carbon double bond takes place. Okay. Now, if we have this compound CH3, CH double bond CH2. If I add HBr for this, okay, now CH3, CH double bond CH2. If you add HBr, what happens? Now, so if hydrogen attaches to this carbon, then Br will get attached to this carbon. So this is the product that you are going to get. CH3, CH. If hydrogen attaches here, then Br will attack here. That means it will be CH3, CH2, CH2, Br. Okay. If hydrogen attacks here, then Br will. The other way around is also possible. If Br attaches here, CH3, CH, Br, you get CH2H is what you get. CH2H, or you can even write it as CH3. Just to show that there is an addition, I have written it like this. So it is CH3, CH2, CH2Br, CH3, CHBr, CH3. So what is the difference here is here. So if hydrogen attaches to this carbon, then Br will attack here. If the hydrogen attacks this carbon, then Br will attack here. So both the possibilities are possible. So out of these two, one will be major product, other will be minor product. What is a major product? Major product is the compound that is present in larger amount is called as a major product. And during the addition of this HBr, to an alkene, these alkenes are called as unsymmetrical alkenes. What are unsymmetrical alkenes? Unsymmetrical means there is a carbon-carbon double bond here. Either side the groups are different. So I will give an example for symmetrical alkene. It is somewhat like this. So there is a carbon-carbon double bond. This side also there is CH3. This side also this is CH. So this is a symmetrical alkene. Okay. So here CH, CH. This side it is CH3. This side no CH3. That means this is an unsymmetrical alkene. So this reagent is also unsymmetrical because HBr will dissociate to give H plus Br minus, two different. So when an unsymmetrical reagent adds to an unsymmetrical alkene, the product formed is governed by a rule which is called as Markovnikov's rule. There is a rule which is called as Markovnikov's rule. Markovnikov's rule. According to Markovnikov, whenever an unsymmetrical reagent adds to an unsymmetrical alkene, what he says is here, negative part of the reagent. Negative part of the reagent means here it is Br minus. Negative part of the reagent attacks the carbon containing least number of hydrogen atom. negative part of the reagent attacks the carbon containing least number of hydrogen atoms. Out of these two, which is the carbon containing least number of hydrogen? See, this carbon has one hydrogen, this carbon has two hydrogen. So this is the carbon containing least number of hydrogen. So negative part attaches here. So this will be the major product. So this will be the major product. And this will be the minor product. Minor product. So this will be the major product and this will be the minor product. That is what he says. So this is called as a Markovnikov product. You can even refer this as an anti-Markovnikov addition. Okay, there is nothing called as an anti-Markovnikov addition. The minor product is generally referred as an anti-Markovnikov product is what we call it as. So whenever an unsymmetrical reagent attacks the unsymmetrical alkene, the negative part of the reagent will attack the carbon containing least number of hydrogen atoms. Okay, let us go for this reaction once again. Now, so same compound CH3, CH, double bond CH2. When you add HBr, so what happens? Negative part of the reagent, which is the negative part of the reagent, Br minus, will attack carbon containing. See, addition should occur across this only, either to this carbon or this carbon. Here addition will not take place because this is not a double bond. So addition takes place across the carbon-carbon double bond. Addition should occur here and here only. So negative part is Br minus, where it will attack carbon containing least number of hydrogen atom. CH3, CH, Br, CH3. CH3, CH, Br, CH3. So this will be the major product. So the negative part of the reagent will attack the carbon containing least number. So this is called as a Markovnikov's product is also we call it as. Okay, now if you carry out the same reaction in presence of peroxide, if you carry out the same reaction in presence of peroxide, what are peroxides? Peroxides are the compounds that contain an oxygen-oxygen bond. Then anti-Markovnikov product will be the major product. Okay, see, when you add this, when you using only an HBr, negative part of the reagent will attack the carbon containing least number of hydrogen atom. But when you carry out the same reaction in presence of peroxide, the negative part of the reagent, that means it will attack the carbon containing more number of hydrogen atom. That means attack of Br takes place here. So we get this compound CH3, CH2, CH2, Br. That means negative part will attack here and H will attack here. So this is the major product that you are going to get. That is 1-bromopropane is what you get. Okay, we will go through some other examples also. Take this. HBr in presence of peroxide. If you don't use peroxide, if you are not using peroxide, Br will attack to this carbon containing least number of hydrogen atom. When you are using peroxide, Br will attack to carbon containing more number of hydrogen. What is the product? CH3, CH2, 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 Br. This is the product that you are going to get. So it will attack here only. So you are going to get 1-bromobutane is what you are going to get. 1-bromobutane is what you are going to get. Right? Right? Or else this one. Let's take this. CH3C, CH3 double bond CH2 plus HBr. Okay, now if you add only HBr and if you add peroxide, see the difference. If you add only HBr, the negative part of the reagent will attack the carbon containing it will attach the carbon containing least number of hydrogen atom. That means Br will attack here. So the product will be this CH3C, CH3, CH2, right? CH3, C, CH3, CH2. Negative part will attack here. So you are going to get this product. If you use peroxide, what happens? The negative part will attack the carbon containing more number of hydrogen. So Br will attack here. The product is, this is what you are going to get. See? CH3, you have CH2, right? This attack will take place here. So Br will attack here. Then hydrogen will get. So this is the product that you are going to get. So this is we refer it as an anti-Markovnikov product is also you can call it as. So whenever you use peroxide, and another thing is peroxide is effect is observed only in the addition of HBr, but not in the addition of HCl and HI, because HI bond is stronger, hence it does not break homolytically, because we are going to see the mechanism of this. So in mechanism you will find that, so whenever you use peroxide, homolytic fusion takes place. That means symmetrical breakage of bond is what occurs. So what I want to make a point here, so we are dealing with the addition reactions. When we are considering the addition reactions, so the product form is governed by a rule which is called as Markovnikov rule, which says that negative part will always attack the carbon containing least number of hydrogen atom. If you use peroxide, then in the addition of HBr, then the Br will attack the carbon containing more number of hydrogen atoms. Okay, let us go through the mechanism of this. So that we will have a clear idea regarding this, right? Mechanism of peroxide effect. So this effect is called as a peroxide effect. We call this effect as a peroxide effect. Now, what is the peroxide effect? Peroxide effect is this one. We'll take this example. CH3, CH, double bond CH2. If you use only HBr, if you use negative part of the reagent attacks the carbon containing least number. CH3. This is what is product obtained. If you use peroxide, then what happens? CH3, CH, when addition takes place, double bond will get converted to single bond. Now the question is where it will attack? Carbon containing more number. So here Br, here it will be HCH2. This is the product that you are going to get. So here Br, here H2, double bond gets converted into single bond. Right? Now, so let us go through the mechanism of this. Let us go through the mechanism. Mechanism refers to the step involved. Okay, now this reaction takes place in 3 steps. One is chain initiation, chain propagation, and then comes the chain termination. We come across chain initiation, chain propagation, and the chain termination is what we come across. Let us start with the chain initiation reaction. So peroxides are the compounds that contain an oxygen-oxygen bond. For example, R, O, O, R. If R is hydrogen, then it is an hydrogen peroxide. You know this. So first step is chain initiation. But what happens is, if you have a peroxide, this breaks homolytically. When you monitor, when you look at the reaction, they break homolytically. When there is a homolytic fusion, what happens? One electron will be taken up by oxygen, other electron will be taken up by another oxygen. So chain initiation means formation of a free radical from a neutral molecule. So peroxide undergoes homolytic fusion to give you free radicals. So what happens with this free radical is here. So this is the chain initiation step is what we call it as. Even it can, a new free radical may be formed by this, and another free radical may be formed in the reaction. So let us go through this now. Second step is chain propagation. So this is chain initiation where a new free radical is formed. In a chain propagation, a free radical, what happens is a free radical, what it will do is it will combine with HBr. So a free radical will combine with neutral molecule. It will take this H to form ROH, and a new free radical is generated. So we have 2 electrons here. So these 2 will combine OH, a new free radical will be formed. So the electron moves here. So this is chain propagation. So chain propagation takes place further also. This Br formed, it will combine with the propene, that is that CH3CH double bond CH2. Okay, Br, so neutral molecule and another free radical will combine to give you another free radical. So what happens is here, Br, electron moves here. So this will attack the carbon content, here it will attack. So here a free radical is generated. So what you get is CH3, CH free radical, CH2Br. So whenever a neutral molecule and a free radical combine, you get a free radical only. See here, neutral molecule, so here there is an addition taking place. A free radical, neutral molecule. So this free radical will form a neutral molecule and a new free radical is generated. So this free radical will combine with neutral molecule to form another free radical. So this is called as the chain propagation step. So what is chain initiation? In chain initiation, a neutral molecule will form a free radical. Chain propagation, a free radical will form another free radical. This is how the chain propagates. Okay. Next comes the chain termination reactions is what we come across. So in chain termination reaction, what will happen is a free radical will combine with another free radical. A free radical will combine with another free radical to end the product. Okay. In chain propagation, there is another reaction that I need to discuss. So what happens is this free radical that is formed, that is CH3, CH, CH2Br will combine with HBr. This will take up one H. So you get CH3, CH2, CH2Br plus Br free radical is generated. So this free radical that is generated, again it will react with another molecule of ethene to give you this. This will again react with HBr. So this process goes on. So chain initiation is a free radical is formed. Chain propagation, a free radical will combine with a neutral molecule to generate another free radical. Okay, here also see new free radical. This free radical will again combine with neutral molecule to generate another free radical. So this is called as the chain propagation step. So last step is chain termination step. Chain termination is end step. Eventually two free radicals hit each other and produce a molecule of some sort. This process stops here because no new free radical is present. For example, so the Br formed here can combine with another Br free radical to form Br2. So no free radical is formed here. So this is a chain termination step. This is the chain termination step. So this is how actually the reaction takes place. That is the peroxide effect. In peroxide effect, the reaction takes place in three steps. One is chain initiation, chain propagation, chain termination. In chain initiation, what happens? A peroxide will give you free radical. This free radical formed will react with HBr to generate another free radical. This free radical will react with ethene to form another free radical. So this is how the reaction step goes on. Okay. So this is about the peroxide effect. Okay. Now let us discuss another simple reaction that is there. Okay. The another very important reaction that we need to discuss is ozonolysis. Let us see what is this ozonolysis. Okay, the name itself indicates ozonolysis. That means we are using ozone here. So this reaction involves addition of ozone to alkene to form a cyclic product called ozonide, which on reduction with zinc and water gives two molecules of carbonyl compound. So let us see this. Carbon-carbon double bond, ozone, CCl4. Okay, now, so addition of ozone takes place to form an intermediate. When addition takes place, double bond gets converted into single bond, ozone. This is unstable, so this rearranges to this compound. This is called as ozonide. carbon-carbon double bond, ozone, to form this structure. Okay, it gives you cyclic ozonate. It gives you cyclic ozonate. Initial addition product is, this is an addition product that takes place. Then it rearranges to give you an ozonate. Okay, so this cyclic ozonate that is formed. See, this is a carbon-carbon double bond. So one oxygen adds across this, two oxygen will add like this. This is what is, right? Whenever it is treated with zinc and water, it breaks. How it breaks is here. So we have C, two bonds here. So this oxygen, it will be double bond over this one. C, two bonds here. This oxygen will have double bond. So you get two molecules of carbonyl compound is what you get. Okay, so this zinc goes as zinc hydroxide, right? So this is ozonolysis reaction. Let us look at the particular examples of this so that you will have a clear idea regarding this. Yeah, let us take an example. We have CH3, CH, double bond CH, CH3. When we treat it with ozone, what happens? Addition takes place and then rearrangement. So what you should do is here, add the carbon H, this CH3, this carbon CH3H. Okay, addition takes place, both the double bond goes off. So since there are two bonds here, so one oxygen adds like this. So another oxygen, this is what is formed. This is a cyclic ozonate structure. When you treat this with zinc water, this breaks. So what you get? You get like this. See, CH3, CH, double bond O. So this is acetaldehyde is formed. Okay, let us take another example so that it will be clear for you. It will be clear for you, right? Now, CH3, C, double bond C, H, CH3, CH3, right? Now, when it is treated with ozone, what happens? See, this carbon. What happens? So it is plus this is what is formed. CH3 C double bond O CH3, CH3 C double bond O H. So you are going to get one molecule of aldehyde and one molecule of ketone. So this is acetone is what you are going to get. This is acetaldehyde is what you are going to get. This is what you are going to get. Right? It is clear with this. Right? So this reaction is called as the ozonolysis reaction. In ozonolysis, ozone adds across this carbon-carbon double bond and then rearranges to give an ozonate, which when treated with zinc water, so the bond breaks like this. This is what you can remember. CH3 C double bond O CH3, CH3 C double bond O H. This is what I want. Okay. Now another reaction that we are going to discuss is oxidation with K-4. So very simple reaction it is. So alkenes undergo oxidation in presence of oxidizing agent like K-4. The reaction is oxidative hydroxylation or oxidative cleavage. That means you get alcohols here. When alkene is treated with dilute alkaline K-4, syn hydroxylation takes place. Syn hydroxylation means addition of OH takes place on the same side. Like the two OH groups are added on the same side. Let us take this example. So we have a carbon-carbon double bond, 2 bonds, carbon valence is 4. This is how we show it. When we treat it with KMnO4, okay, KMnO4 is like this: Mn, double bond O, double bond O, double bond O, O minus is what? K plus MnO4 minus is KMnO4. So what happens? This is a double bond here. This attacks here. The electron move here. This attacks here. So a bond between these two oxygen takes place. So this is a cyclic intermediate it is formed. CH. Okay, we will keep it as it is. Okay. Okay. Now double bond gets converted into single bond. Oxygen. Mn. This oxygen here. Double bond O. O minus. The electron that has shifted here. This is what you are going to get. This is the cyclic intermediate that you are going to get when this is treated with OH minus in presence of water. What happens? This becomes OH, OH. You get diols. Diols, molecules with 2 OH groups are referred as diols. And this Mn goes off as MnO2. Okay, now let's take a specific example. See, H2 double bond CH2. Okay, this undergoes oxidation in presence of KMnO4. Okay, so oxidation in presence of cold KMnO4 and in presence of this OH minus. So what happens is here, cold KMnO4, OH minus. The reaction takes place in presence of water. Okay, basic medium is required. So what happens? Across this double bond, you get this compound CH2 double bond. This single bond you get OH and OH. Addition of OH takes place. This is called as syn addition because addition of OH takes place on the same side. So this is what is happening. So this attacks oxygen, this oxygen attacks this carbon. So you get a cyclic intermediate. When treated with OH minus and water, you get OH. OH is what you get. Let's take another example for this so that you can write the product for this. CH3, CH, double bond CH, CH3. Cold KMnO4, OH minus, CH3, CH, CH, CH3, OH, OH. Double bond, single bond getting converted, OH, OH. You get diols. So that this is butane 2,3-diol is what you are going to get. Okay, hope this is clear. So this was about the peroxide effect, then ozonolysis reaction as well as reaction with cold KMnO4. Okay, thank you.